In this video, I'll be demonstrating the new camera position optimization tool found in PCCrash 10.1. The camera position optimization tool allows a user to match a 2D photo taken of an accident scene and match that to a 3D laser scan, a DXF drawing, or even an aerial image. So let's get started. In this example, I will be trying to match this photo. We can see in this photo there are two markings in the middle of the road. A straight line, which could be, for example, a mark of a skid mark, and a circle here, which could be a rest position. Now, in this photo, we don't know exactly where the photo was taken from, so we'll be using PCCrash to find the camera position and then virtually applying these marks within PCCrash. So in this example, we will be using a 3D laser scan of this scene and matching it to this photo. So first we load a point cloud. This can be done by simply dragging and dropping the XYZ file into PCCrash. And now we let the PCCrash load the point cloud. And now the scan is loaded into PCCrash. If you take a look at our 3D window, we can roughly see the same objects as we saw in the photo. We have the stop sign, the stop line, the center yellow line, and some signs in the back. So what we'll try to do is match the photo found here with our 3D point cloud. The goal of it is to virtually place these road markings into our PCCrash project. So to do so, within our PCCrash, we will load the 2D photo as a background bitmap. So we're going to load bitmap. We will navigate to this photo, and we will load that in. So now we see the photo loaded as a bitmap as a background. So new for PCCrash 10.1 is the Optimize Camera Position tool, which will allow us to easily find the position in which this photo was taken. So to aid that, we will first go into display options and have our background image shown in the foreground. Now, what we will do is select a few common points between the photo and the scan so that the PCCrash optimization program will know roughly where everything is. So let's get started with that. So we will go into camera calibration points, add, and then our toggle here changes to BMP, which means our background bitmap. So what we'll do is now we will select a point on the photo, and now the toggle changes 3D. So now PCCrash is telling us to select the same point in our 3D window. So what we can do is temporarily turn off the background image and navigate through to our point cloud and select the same point. So now we see a common point has been selected. We can repeat this process several times, such as at the stop line here, at the stop line here, at the intersection with the center yellow line, maybe this sign back here. To move around in your point cloud, we can hit this toggle between camera and pick mode. Once this is unselected, we can freely move within the point cloud. Once this thing is selected, we will be selecting the common points. We can do this again for this sign over here. We can zoom out over here. We can also select maybe this light post here. In order for the PC Crash camera position optimizer to work, we need at least 4 points, preferably some within the foreground, some within the background, some within the left side of the frame, some within the right side of the frame. This way, with more points, the more accurate the camera position optimization tool can be. So once we have our points selected, we can go into optimize camera position. And now PC Crash will try to optimize our cameras such that the common points are common to each other. So now we see PC Crash has found a good match. However, we see the foreground's points are very good, and there are some slight errors in the background over here. Now, this background could be an issue caused by the tilt of the original photo. In order for the PC Crash camera position optimization tool to work at its optimal, we want the horizon to be flat. And in this case, we see the photo is slightly skewed to the right. So using the background image rotation tool here, we can simply rotate our background image such that the horizon is flat. And once we've done that, we can rerun the camera optimization tool. And now we see the match is a lot closer. So with that, we can now save our camera position by either going into View, Save Camera, and we can save this view, maybe South View, and now this position is saved. So now what we can do is try to virtually place these markings back into our scene. What we can do here is go into our point cloud, so back in our 2D view, and we know the markings were somewhere along in this area. So we can select our point cloud, select the area in which we know those markings were at, maybe here, and now we can select the recolor selected points. What this tool will do is it will take into account the 2D image that we imported before, and with the camera matching, it will try to recolor this selected orange area with the colors from our 2D image. So we can select that. And now we see the markings on the road transcribed onto our PC Crash point cloud. So now with these markings, we are now able to do a reconstruction. Thank you for watching this video. This has been the PC Crash 10.1 camera background position optimization tool demonstration.